Okay, hey guys, I'm back. I took a little break, was looking at the solution, and I think I understand. Like when I read the solutions, I don't read it like word for word. I just kind of glance at it, and I kind of understand what we have to do. I think the hints give me more like info on this. So first of all, I was trying to do dynamic programming, like memoization, and that can't work for this. We have to use binary search. And I still need to get good at identifying when to use binary search because to me it's not obvious that this problem will even use binary search. But okay, what are we using binary search on? Because we're not using it on this array. This array might not even be sorted, right? We need to find the bounds of our binary search. So binary search is definitely going to be used, but what are the bounds? Um, I think like the bounds could be like the min, and they say it here. Initialize the search range with the minimum and maximum elements of the input array. So that's fine, right? The left pointer will be min of nums. The right pointer would be the max of nums. And then, okay, in hint 3, it says we need some sort of check function to determine if it's possible to select k non-consecutive elements that are less than or equal to the current guess value. Yeah, the only question I'm thinking right now is what if we had like what if our guess value was like a 4 and we had 1, 3, 4, 6? So if we chose this one and chose this one, then we're good. That's 2. But would we ever want to skip, like if we go left to right, would we ever want to skip this one and choose this one? Not really, right? Because then the reason why we choose that is because we wanted this one, but it's 6. But what if it was like a 2? Then sure, we can choose that one. But then we might as well, if this was a 2, we might as well have just chosen 1 and 4 because that still works. Or if we chose 1, because that's the first thing we saw, and this was a 5, let's just say, then we're just going to skip over those and just click here. So either way, we're getting to 2. There's no way 1, 3, 4, 2 will give us anything other than that. Or 1, 3, 5, 2 in that case. Okay. Adjust the search range based on the outcomes. Okay. So I guess that's fine. Um, just have a helper function, right? Is possible with maybe I'll call it target, but let's be explicit here. So we know it's going to return some sort of boolean, and then I guess this is going to be, is it possible to select k non-consecutive elements that are less than or equal to target. After that, like I said, our left is just going to be the minimum of nums. Our right is going to be the maximum of nums. Result is just going to be, they want the minimum, right? And it's guaranteed to be in here. So I think I'm just gonna I'll just set it to none. Then I'm gonna say while left less than equal to right. We're gonna get mid, which is left plus right minus left divided by 2. If is possible, this is where we call it with mid. Then go ahead and put our result to mid. But we want to find something potentially smaller. So we do right is equal to mid minus 1. Otherwise, left equals mid plus 1. We just need to return our result. Okay, that's fine. Is it possible to select k non-consecutive elements that are less than or equal to target? I mean, since it's not sorted, the array nums isn't sorted, we probably need to do something linear, right? So like for n in nums, is it possible to select k? So I want this count to be 0. We just need to process some consecutive stuff and up the count. After that, we would just return, is that count greater than or equal to k? Right? So when are we going to up the count? As soon as we see it, right? So like if n, oh, actually this might be while I could be 0, while I less than length of nums. While I is less than length of nums, if nums at I is less than if nums I is less than or equal to the target, then we're going to use it. So count plus equals to 1, I plus equals to 2, because we can't use the neighbor. Otherwise, let's just check the very next one. I plus equals to 1. Okay, I think that's it then. Okay, that worked. And let's just submit it. Nice. Yeah, this problem did not feel good. I mean, I had to stop recording and look at the hints, look at the solution, but it makes sense. And it's kind of annoying because these binary search problems are all the same. It's all like this binary search is easy, right? We just like have a left and a right bound. I think the hard part is what is that left and right bound? In this case, it's the minimum of nums and the maximum of nums. And then we always have this like helper function that says, hey, can we process mid? Is it possible? So yeah, that kind of sucks. But let's look at the time complexity. This is going to be log n, where n is like the max. I don't know, it's kind of weird, right? Or maybe m is equal to the max of nums. Log of m is the time complexity, but then inside is possible, we're doing just like a linear left to right search. So that's just going to be O of n, where n is the length of nums. So I think it's also a n O of n log m time. And then for space, we're not holding anything extra like array or anything, so it's just going to be constant space 01. But yeah, honestly kind of disappointed that I wasn't able to do this one on my own, but it's cool. I'm learning that I need to consider binary search, and I need to work on identifying it, because even though we're in a binary search week, the first like 15 minutes I was trying to use dynamic programming. So yeah, with that being said, see you guys tomorrow.